Hello to everyone here from Meta. Thank you for taking the time today to hear my presentation on how I can help you expand the customer base for your virtual reality chat and gaming platform, Horizon Worlds, using data science. To introduce myself, my name is Nicholas Wertz, and I'm a data scientist from the Flatiron School. I'm here today to tell you how to engage with your customers and retain them for longer. To briefly go over today's agenda, I will begin with the problem facing your business, followed by some information on the dataset I use to develop a predictive model to help solve your business problem. Next, I will go over how I further prepared the data before telling you the results from my modeling. Finally, I will tell you how Meta can use this model and what you can do in the future to further improve your product. So let me ask the question that's on all of our minds. As you develop and expand your new virtual reality chat program, Horizon Worlds, how can I help you to develop, engage, and maintain a loyal base of customers for your growing platform? I believe that we can achieve all of this by implementing emotional tracking software into Horizon Worlds. By incorporating my speech emotion recognition model into your software, we can track the emotions of players in real time and therefore be able to personally engage with users and build customer loyalty. Next, let's talk about the data I used to build my model. All data was sourced from the Emotional Voice database, which features 4 English-speaking actors with Mid-Atlantic accents in a base set of 6,900 audio files simulating 5 emotions. The emotions of the dataset included amusement.
Not in this particular case, Tom. Apologized, Whitmore.
Anger.
Not at this particular case, Tom. Apologized, Whitmore.
Disgust.
Not at this particular case, Tom. Apologized, Whitmore.
Neutral sentiment.
Not at this particular case, Tom. Apologize, Whitmore.
And finally, sleepiness.
Not at this particular case, Tom. Apologized, Whitmore.
As you can tell, these are all fairly random phrases used by the actors to emphasize the sentiment as clearly as possible. As you can see from this graph, I had more recordings of sleepiness than any other emotion, with there being around 1,700 sleepiness recordings, but there were no major data imbalances. Each audio clip was pre-processed before being used on the model. Each clip was trimmed of silence and broken into 2-second clips. The testing clips were left untouched, and the clips used for training were randomly given noise and had their pitch and speed randomly adjusted. This was done in order to generalize the model. Both audio sets were then converted into a spectrogram, a visualization of sound data. These spectrograms are what were used for training and testing the final model. After this processing stage, I had nearly 16,800 spectrograms on which to build the model. So for my model, I used a convolutional neural network to analyze each spectrogram image. Categorical accuracy was used as my main metric, as I wanted to see how well the model could identify the emotion represented in each spectrogram. I also used F1 scores as a secondary metric to judge the model's performance, as it combines precision and recall scores for each emotional class. So here are the results of my best CNN model. After 10 cycles through the data, I was able to achieve a test accuracy of 74% with minimal loss. Moving on to our secondary metric, F1 scores. The model excels at identifying sleepiness with an F1 score of 88%. If you remember previously, we had the most base audio clips of the sleepiness class, so the result makes sense. The worst F1 score was for neutral emotion, which had an F1 score of 59%. This also makes sense, as being totally neutral in emotion is almost impossible. To have a truly neutral audio performance, any hint of any other emotion would have to be absent. So much of the neutral data may have leakage from the actor's true emotional state at the time of recording. So now that we have a well-performing predictive model, what should you use it for to improve your customer retention? One option using my model would be to animate users' in-game avatars to express their current emotional state when interacting with other players. That is going to better simulate real-world interactions between users and allow your users to engage with each other more, and by extension, become more engaged with Horizon Worlds. That will foster a community and create a much more loyal user base for your platform. Also, knowing the changing emotional states of your users can be beneficial for customer retention. For example, if you see that a user is less satisfied with some aspect of your platform, you can prioritize their desires when developing features in order to keep them using your service. You can also use my model for forms of targeted advertising. More satisfied users can be targeted with special offers and in-game events to reward them for being loyal to the brand and to continue growing your user community. As we move to the future, I can develop this model even further by incorporating data from users of Horizon Worlds. For example, as of now, the model utilizes 4 actors with mid-Atlantic accents. We can further generalize this model by taking real user audio with a diverse set of accents and retraining it to further improve scores. I can also create new models for other languages, as they often emphasize parts of speech that are different from English and therefore would result in a different spectrographic image. Once I'd created models for a few of the more common languages, you can begin implementing these features based on my model into Horizon Worlds globally. Thank you for your time today. I've been your data scientist, Nick Wertz, and I'm looking forward to working with all of you. If there are any questions, please leave them in the Q&A section below or message me on LinkedIn or GitHub. Thank you.